Have you ever wondered what happens inside your body when you get hurt or sick? It all comes down to your cells, the basic building blocks of life. Cell injury and death are fundamental processes in pathology, the study of disease. Cell injury occurs when cells are stressed by harmful stimuli. These stimuli can be anything from physical trauma to infections. Think of it like pushing a cell to its breaking point. When the stress is too much, the cell can no longer function properly. If the injury is mild or temporary, the cell may recover. However, if the injury is severe or prolonged, the cell may die. Cell death is the ultimate consequence of irreversible cell injury. It's a bit like a machine breaking down beyond repair. Understanding the mechanisms of cell injury and death is crucial for doctors like me. It helps us diagnose diseases, understand how they progress, and develop effective treatments. Now let's dive into some common ways cells get injured. It's like a rogues gallery of cellular villains. One major culprit is hypoxia or lack of oxygen. Cells need oxygen to produce energy. Without it, they're like a car running out of gas. Then there's oxidative stress damage caused by unstable molecules called free radicals. Imagine these free radicals as tiny wrecking balls bouncing around inside your cells. Mitochondrial dysfunction is another way cells get hurt. Mitochondria are like the powerhouses of cells. When they malfunction, it's like a city losing its power supply. Calcium imbalance can also wreak havoc. Cells need calcium for many functions, but too much or too little can be toxic. Membrane damage is another serious issue. The cell membrane acts like a protective barrier. Damage to this membrane is like breaching a castle wall. Protein misfolding is like a cellular game of Tetris gone wrong. Proteins need to fold correctly to function. Misfolded proteins can clump together and cause problems. Finally, inflammatory mediators are like the body's alarm system, but sometimes they can overreact and damage healthy cells. When cells face severe and irreversible injury, they often undergo a process called necrosis. This is a messy and uncontrolled form of cell death. Imagine a balloon bursting. That's kind of what happens during necrosis. The cell swells, its membrane ruptures, and its contents spill out, causing inflammation. There are various types of necrosis, each with its own characteristics. Coagulative necrosis is like frying an egg. The cell proteins denature and solidify. Liquefactive necrosis, on the other hand, is more like melting butter. The cell dissolves into a liquid mass. Caseous necrosis is like crumbling cheese. It's a combination of coagulative and liquefactive necrosis. And then there's gangrenous necrosis, which occurs when a large area of tissue dies, often due to lack of blood flow. Section 4. Apoptosis, programmed cell death. Unlike necrosis, apoptosis is a more controlled and organized process of cell death. It's like a planned demolition of a building rather than an explosion. Apoptosis is a normal part of development and tissue maintenance. It helps eliminate old, damaged, or unwanted cells. During apoptosis, the cell shrinks and breaks down into small membrane-bound fragments. These fragments are then engulfed by specialized cells, leaving no trace. This process is essential for many reasons. It helps shape tissues and organs during development. It removes cells that are no longer needed or that pose a threat to the body, like damaged cells that could become cancerous. Section 5. Autophagy and the consequences of cell injury and death. Autophagy is another cellular process that deserves mention. It's like the cell's recycling system, where it breaks down and recycles its own components. Cell injury and death, whether through necrosis or apoptosis, can have significant consequences for the body. When cells die, they release molecules that trigger inflammation, a complex process that involves immune cells and signaling molecules. Inflammation is a double-edged sword. It helps eliminate harmful agents and repair damaged tissue, but excessive or chronic inflammation can contribute to various diseases. Understanding the intricacies of cell injury and death is crucial for diagnosing and treating diseases. By understanding how cells respond to stress and injury, we can develop targeted therapies to prevent or slow down disease progression. From heart attacks to neurodegenerative diseases, many conditions involve cell injury and death. By unraveling the mysteries of these processes, we can pave the way for new and innovative treatments to improve human health.